Okay guys, this is example 3 torque. We're dealing with a clock. Remember, let's change the pins. Let's go black. Hit a Control Z to back up to erase the last couple steps. Hands of a clock and a famous clock, 2.7 meters long, 4.5 long, and have masses of 6 kilograms and 100 kilograms respectively. What you want to make sure you do is, let's split this in two pieces. The hour hand goes straight up, and then the 8 o'clock hand goes down to the left. You know there's 360 degrees in the clock, so that means each hour is a mere 30 degrees. That's going to be important because when we talk about torque for each hand, we need to find that perpendicular distance. The pivot point is the center for each one of them, so I'm going to draw them in two pieces. If you look at this first piece right here that goes straight up and down, you know torque is equal to FD, but there is no angle between them. There's no distance from this pivot point, so his torque automatically becomes 0. Okay, now if you look at this angle right here, no big deal. You have to be careful, and let's get this perpendicular component of this distance. Remember, the mass of this guy goes straight down, so we've got to figure out that's his force is going straight down, so we need to get the perpendicular component of this distance right here, right there. So what I'm going to do is draw you a triangle so you can see that that angle is 30 degrees. Okay, we need this x component, so in this case the distance we need, dx, is going to be, the distance is 2.7, because that's the length of the arm right here. 2.7 times the cosine of 30, because you want the x component. Remember, that's a terminal angle. So now let's take 2.7 times the cosine of 30. That should give us, get the handy dandy calculator, slide it over here. We're going to put in 30 first, hit the cosine, times 2.7. That gives us 2.34. We know that distance is now 2.34. So now we have the x component of the arm, which looks like this. You know the force goes straight down, but notice I put it from the center because that's the pivot point. Anytime you have a ruler or a stick, you want to deal with the distance from the center. Half of $2.34 is $1.17, so half of 2.34 is 1.17. Now you have a pivot point, you have a level arm, and you have a perpendicular force. The perpendicular force is going to be mg. So now your torque simply becomes mg times d, which is equal to your mass of the arm. The minute hand is 60 times 9.8 times 1.17, and that should give us, let's get the handy dandy calculator out again. I lost it. I don't know what I did with it. Let's see if we can find it. It's always your calculator, but you always know there's one in accessories, and I try to leave it floating, but I forget every time, so bear with me. 60 times 9.8 times 1.17 is equal to 687.96, and you know that those are what? Newton. I'm going to write it up here, forgive the sloppiness, but it makes sense, Newton meters, because remember, torque is simply force perpendicular to the distance, the level arm, and that should be your answer. That's example 3, torque on example sheet. Thanks.